This video will walk you through the steps as to how to evaluate the determinant of a matrix. We are going to look at in this video how to find the determinant of both a 2x2 and a 3x3 matrix. This knowledge is important because you will apply it to solving systems of equations using a couple of other skills using matrices called Cramer's rule and inverse matrices, which you will learn about in a little bit. Let's talk about how to find the determinant first of a 2x2 matrix. So as you can see here at the top of the screen, to find the determinant of a 2x2 matrix, typically you'll see it notating one of two ways. You'll see DET out front, which means determinant outside your matrix brackets. You might also see it with these straight up and down lines. They kind of look like absolute value bars, but this is just more of a notation thing for determinant of a matrix. It's a slightly bit form of shorthand. But to find it by hand, all you have to do, find the product of the diagonal starting from the top left, take it away from the product of the diagonal starting from the top right. You can see it with the letters here, and I'll show you with numbers in just a moment how to do that. So there's not a lot of math to be done. It's just a matter of making sure you do it accurately. So if you look at the example underneath where it says find the determinant of the matrix 5, 4, 3, 1, by hand, all we have to do is find the product starting with the top left diagonal. So we'll start off with 5 times 1. Take it away from the product of the diagonal from the top right. Minus 4 times 3. Not very complex math. All you have to do there is quick amount of order of operations. So we get 5 minus 12, which gets you a final answer of -7. Now, you can always check this using your graphing calculator, and since you now know how to enter in a matrix, you can go ahead and use the matrix menus to your advantage. So, let's go ahead and enter this matrix in first, and then I'll show you how to find the determinant using the correct buttons. So, second, your inverse button pulls up the matrix menu. Now, there was already a matrix in from a previous video, so I'm going to go ahead and edit it. Take that first slot. Since it's already set up as a 2x2, I don't even need to worry about dimensions. But I am going to change my elements because this is not 1, 2, 3, 4. It's 5, 4, 3, 1. So remember, after each element, hit enter. Check to make sure that what's on the screen matches what's on paper. It does. Great. Now we're going to quit out of it. Now, to actually do math with it, we need to go back to the matrix menu. So since we're doing math, we're going to scroll over to math. How convenient. First option says DET for determinant. Also convenient. We're going to go ahead and hit enter. So you'll see on the main screen DET with an open parenthesis. Now we're going to go ahead and enter in the matrix. So, second in matrix. We already have entered it, so we're going to stay in this names tab. We're going to go ahead and hit enter since we entered it in for slot A. Close our parenthesis for good measure. And we get the same answer. Calculator does its magic, does the same exact operations we just did on paper, gives us a determinant of -7. So, you might find for 2x2s, while the calculator again is very great, it's a great way to check your answer. Most of you can probably do math like that pretty quickly, but this is always a great way to check to make sure that your work is correct. As you do more complex things like Cramer's rule and inverse matrices, this number has to be right in order to do the other steps required for those. So it's always good. Use your calculator to check to make sure you didn't screw up any mental math. Now, that's a 2x2. The 3x3, you can see sort of at the top here. So I'm going to move the calculator out of the way for a second. To find the determinant of a 3x3. So, 2x2s are nice because you do a couple quick diagonals, it accounts for all the values. Awesome. 3x3, if I just did an X over it, the top left and the top right, it doesn't account for all these values around the side. So what we have to do is rewrite the problem so that we take the first two columns, rewrite them on the outside, so we can account for all the possible combinations of numbers to put together, all these supposed quote-unquote diagonals. So, in order to do this by hand, you can see this is a lot more cumbersome than a 2x2. I'm still going to show you how to do it, but there's a lot more work to it. So, let's walk through the steps here with the second example. The way that we're going to do it is we're going to take the first two columns and rewrite them on the outside. So 2, 4, 3, -1, 1, -4. We're going to copy those. So in order to get the determinant by hand, all we need to do, and I say all, but there's 6 of these that we have to do. We have to go ahead and find the products of all the diagonals that account for all the different values we're going to need. So we are going to take all the diagonals that start from left down to right. So you'll notice the 2, 1, -2, -1, 0, 3. -3, 4, and -4. We're going to find the product of all of those and add them together. So 2, 1, -2 make -4. -1 times 0 times 3, well, that's 0, that's easy. -3 times 4 times -4 makes positive 48. That takes care of all the diagonals that run from left to right. We are going to subtract that from the sum of the products of all the diagonals going the opposite direction, from right to left. So that's going to be these three guys right here. So now you still might be wondering, well, why weren't that 4 and that 1 circled off? Still doesn't look like they're being used. They are being used because they've been integrated in other parts of the diagonals. So every value is getting used at least once so that we can find the determinant. This is still being used correctly. So now I got to look at these diagonals here. So again, I'm just going to put the products together here real quick. -3 times 1 times 3 is -9. Plus, so again, we're doing the second part here. 2 times 0, well, there's a 0, so it's just going to be 0. -1, -2, and 4 make a positive 8. So again, we're going to take all of these. So I take the first set of diagonals, add them together, and get 44. Take the second set of diagonals, I get -1. 44 minus -1 is like 44 plus 1. You get 45. So again, it's not complex math, but there are several steps you have to take to make sure it's written correctly. There's a lot of little operations that you have to do to combine it together. However, you have a calculator. If you have to find the determinant of a 3x3 matrix, it might be easier to use this. So again, by hand, it's always good practice to do. The calculator for sure will check your work. So we're going to go ahead and enter in a new matrix. So I'm just going to edit out and clear out the first one. So this is a 3x3. Let's enter in a 3x3. Now, you want to make sure you take your time in putting all the values in the correct spots. So the first row will go in 2, -1, -3. Next row is 4, 1, 0. Bottom row is 3, -4, -2. Now you notice I'm only entering in the original matrix, not all the random stuff I wrote after it. That's stuff you have to do if you're doing it by hand. So here's my 3x3 matrix. Quit back out of it. Again, I want to find the determinant, so I'm doing math. Let's go to math. Option 1 is determinant. Go back to your matrix menu. That's the 3x3 we just entered. Again, in the names column, that's where you pulled from so you can actually do operations with it. Close off your parenthesis and check it out. Does its magic, and you get 45. So, for either of these, whether it's a 2x2, 3x3, there are certainly other matrices that this can be used for, but for our purposes, this is as far as we're going to go. My suggestion would be, you can definitely do them by hand. If you aren't sure that what you're doing by hand is correct, you do have the calculator to your advantage, but you have to know how to input it correctly. For a 2x2, it might be just as fast or even faster for some of you to do it by hand. A 3x3, I would say for most of you, the calculator will work to your advantage. And that is how you find a determinant of a 2x2 or a 3x3 matrix by hand or by using your calculator.